working under the Cal Poly Research Pier. As scuba divers, you're going to conduct vertical transect surveys of the pilings that support the pier. We will hop in the water off this lower landing and swim over to one of the pilings. And over there, attached to it will be a measuring tape or transect that looks like this.
Here is a schematic of the pier piling you will look at while underwater. There will be alternating sections of pink and white or yellow, with each section representing 0.5 meters. Since the pier piling is 1 meter wide, the area we will survey for each data point will be 0.5 meters squared. During the survey, you will count how many sea anemones, sea urchins, and sea stars you observe within each section. For example, we can look at this white section here. How many sea stars are within this square? We can see that there are 2 full sea stars and about 50% of a third star included within the square. We will round up to the nearest whole organism, and since more than 50% of the third star is included, we will round up to 3 sea stars total. If we divide that by 0.5 meters squared, we can calculate our population density to be 6 sea stars per meter squared at this depth. Let's move down the pier piling to the next step. If we look at this pink section, how many anemones are there? Remember, to count as a full organism, more than half of its body needs to be included inside the transect segment. In this case, we'd only consider there to be 2 sea anemones at this depth. 2 divided by 0.5 meters squared gives us a density of 4 anemones per meter squared. For this part of the lab, you are conducting vertical transect surveys. At each depth section of the transect, you will count the number of sea stars, urchins, and anemones you see on the piling, and calculate the population density of each organism at each depth. You will repeat this process until reaching the maximum depth of 4 meters.
There are 3 animals you'll easily be able to observe once we're underwater. There are sea stars, sea anemones, and sea urchins. As you think about how to make a hypothesis about how depth will affect the populations of these organisms, think back to what we've already learned about them. What do they eat? Also, what other resources might they need to survive? Consider how depth might affect the availability of these resources.